Hello, my name is Dallas Driver, and I'm a freshman at Virginia Tech who is majoring in biochemistry. Today I will be breaking down and explaining a paper by Gonzalo about turning a riboflavin binding protein into a self-sufficient monooxygenase by cofactor redesign. Monooxygenases are enzymes that integrate one hydroxyl group into substrates in many metabolic pathways. They implement oxidations of organic substrates while under environmentally non-threatening conditions. Therefore, they are regarded as extremely important biocatalysts. The relevance of monooxygenases is usually hindered by its dependence on cofactors. These cofactors are needed to deliver electrons to the oxidizing cofactor, which could be P450 monooxygenases and flavin and flavoprotein oxygenases. In this paper, it discusses how monooxygenases were paired with cofactor redesign so that they could be self-sufficient. With the binding of alkylated flavins to riboflavin binding proteins, artificial flavoenzymes are capable of hydrogen peroxide driven reactions. When the structure of the flavin is changed, different degrees of which enantiomers of a chiral product can be achieved. Gonzalo addresses how different flavins exhibit a well affinity for riboflavin binding proteins. In this study, he used a concise library of alkylated riboflavin and lumiflavin derivatives. Riboflavin binding proteins were reconstructed with these derivatives. In Figure 1a, it shows the electrostatic surface of the riboflavin binding protein with an ethylated flavin in the binding pocket. In Figure 1b, it compares the energy scores for docking flavins and how each interact with the riboflavin binding protein. From this data, it is concluded that each and every one of the flavins shown have a strong attraction for the riboflavin binding protein. Overall, Gonzalo shows that cofactor redesign is a promising method to create synthetic flavoenzymes with unmatched actions. Gonzalo's work shows that because there are very few other proteins that are able to bind successfully to riboflavin, there is a current exploration of proteins that bind the phosphorylated form of riboflavin.